In this section, we will learn about plane curves and parametric equations. This is a plane curve, a curve on the plane. A plane curve is defined by so-called parametric equations. X and y coordinate of a plane curve are defined by functions from an interval on the real number line. In this picture, f and t are parametric equations. Let me elaborate a little bit. Let's say f and g are functions defined on an interval. The plane curve is the set of points consists of x and y coordinate defined by those two functions. When we put x equals f of t and y equals g of t, then those two equations are called parametric equations with parameter t. These two are parametric equations. Those are just the equations which start at x and y. X equals 2 cosine of t and y equals 2 sine of t. If we combine those two equations, then we can draw plane curve. These two x equations don't use trigonometric equations. However, these are parametric equations. X equals t cubed minus 3t and y equals t minus 1. By combining these two informations, we can draw a plane curve. We will try to figure out how to draw those plane curves from the given parametric equations. To draw a plane curve from parametric equations, we use eliminating parameter method. Parameter in these equations is t. Eliminating parameter method try to eliminate t, and we combine x and y together to form a rectangular equation, and then we will graph the equation of x and y. When you draw a plane curve by using parametric equations, keep in mind that there are three aspects of parametric equations. Those are trace, direction, and speed. We will understand it only after we work out some examples. Let's graph parametric equations. We have parametric equations x equals 2 cosine of t and y equals 2 sine of t. We want to use eliminating parameter method. So we want to try to eliminate t in the equation when we combine x and y. In this problem, we can consider x squared plus y squared, and we will try to apply the Pythagorean identity. Let's do that. X is 2 cosine of t, and y is 2 sine of t. So it became 4 cosine squared of t plus 4 sine squared of t. 4 is a common factor, so we take that out. Then 4 open parenthesis cosine squared of t plus sine squared of t. That is 4 times 1 by Pythagorean identity. This part is 1, so this is 4. When we combine two parametric equations, we could get rectangular equation x squared plus y squared equals 4, which is 2 squared. That is a circle with radius 2 and center 0 and 0. When we graph it, it is just a circle which look like this. I said in parametric equations, there are 3 aspects. One aspect is trace. We figured out the trace, and direction and speed. Direction and speed can be figured out by actually evaluating according to t. Let's pick some sample points and evaluate. We will evaluate at 0, pi over 2, pi, and 3 pi over 2. After you stop this recording, you will fill out this table and come back. This is the table you should obtain. When t equals 0, x value is 2 and y value equals 0. So that is this point. When t is pi over 2, x value is 0 and y value is 2. So this point. That was evaluated by plugging in pi over 2 to the given parametric equations. So 2 cosine of pi over 2 and 2 sine of pi over 2. So when time changes from 0 to pi over 2, we trace the circle in this way. When t becomes pi, x value is negative 2, y value equals 0. Between these two numbers, we trace the circle in this way, and when t becomes t becomes 3 pi over 2, x value equals 0, and y value equals negative 2. This value, and we go this way, and then we go this way to go back to 2 pi, and then we have x value 2 and y value equals 0. So this is the direction, and the actual point we evaluated indicate the speed of the parametric curve. The second question is very similar. However, instead of t, we will use 2t. We have parametric equations x equals 2 cosine of 2t and y equals 2 sine of 2t when t is greater than or equal to 0. We do the same thing. We try to evaluate x squared plus y squared. Then x is 2 cosine of 2t squared plus y is 2 sine of 2t squared. So this one squared is 4 cosine squared of 2t plus the next one is 4 sine squared of 2t. The common factor becomes 4 cosine squared of 2t plus sine squared of 2t. That is 4 times 1, which is 4. After all, we are getting the same rectangular equation, x squared plus y squared equals 4. So 4 was 2 squared. So that is the equation of a circle with radius 2 and a center 0 and 0. So this is the graph. But that is the graph of a rectangular equation, not the parametric equation. So we have to figure out the speed and direction. We will draw the table again. This time we will evaluate at 0, pi over 4, pi over 2, 3 pi over 4, and pi. You stop this recording and you will fill out the table and come back. If you evaluate, then you have to get these values. When t equals 0, x value equals 2 and y value equals 0. And when t equals pi over 4, x is 0 and y equals 2. When t is pi over 2, x is minus 2, and y equals 0. When t is 3 pi over 4, x equals 0, y equals minus 2. When t is pi, we come back to 2 and 0. So we trace the circle counterclockwise. When we compare with the previous example, when we have 2 cosine of t, 2 sine of t, if you look at the circle, then those are the same circles. And the direction are the same. Those are counterclockwise direction. However, this is t, this is 2t. If you look at this, it can reach 0, 2 here when t equals pi over 2. To get to the same point, we took only half amount of time. So by increasing t to 2t, we increase the speed of tracing the circle twice more. So those are different parametric equations. Let's do the similar example. This time we have x equals cosine squared of t and y equals sine squared of t. We use Pythagorean identity again. Then that'll be cosine squared of t plus sine squared of t equals 1. What is given in the problem is that x equals cosine squared t. So instead of cosine squared of t, we write x. Instead of y, sine squared of t, we write y. So we have a linear equation this time. We are more accustomed to the type of equation y equals. So if we solve for y, then it becomes y equals 1 minus x. Before we draw the straight line, let's fill out the table. We will evaluate at 0, pi over 4, pi over 2, 3 pi over 4, pi, and 5 pi over 4. You will stop this video clip and fill out the table and come back. If you filled out the table, then you should get these values. You can compare those. Remember that those points are on the straight line. Other important point you have to keep in mind is x is defined by cosine and y is also defined by trigonometric function sine. So there is a maximum and minimum value for cosine and sine, and that determines the maximum and minimum value of x. From here, x ranges between 0 and 1, and y ranges between 0 and 1. That implies the graph of the parametric equation will be only the part of the graph of the straight line y equals 1 minus x. This is x-axis and this is y-axis. This is 1 and this is 1. This is x range and this is y range. If you draw the graph, then y-intercept is 0, 1. When x equals 0, y equals 1, and x-intercept happens when y value equals 0. If y value equals 0, then x value equals 1. So 1, 0. Those are x-intercept and y-intercept. There are 2 points on the plane, so we can join those 2 by a straight line, and then we get a line segment, and then that line segment will be the trace of the parametric equation. Let's consider the direction of the parametric equation. When x value equals 0, when t value equals 0, it passes 1 or 0. Here, when t equals 0, and when t is pi over 4, it passes 1/2 and 1/2. So we move this direction, and then when t equals pi over 2, the point is 0 and 1. We keep moving toward that direction, but after that, if we evaluated 3 pi over 4, then we go back to 1/2 and 1/2. And so after we follow this, we go back here until we reach 1/2 and 1/2. And when it becomes pi, x value equals 1 and y value equals 0, so we come back this way. When t is 5 pi over 4, we start to move the other way, and we go toward this direction and eventually reach it here. So 5 pi over 4. So what we can imagine is the point will oscillate between this direction and this direction forever. That is the parametric equations curve when x equals cosine squared of t and y equals sine squared of t. Let's do other type of problem. Let's find parametric equations for the curve with the given properties. That is about the line with slope -2 and passing through -20 and -10. The parametric equations we are trying to figure out is the parametric equation of the straight line. So we will set up two equations for x and y. X is a function of t, so x can be written as x of t equals at plus b, and y of t can be written as ct plus d. For our convenience, to make things simpler, we will assume that the parametric equation pass through -20 and -10 when t equals 0. Then we can rewrite the equation as x of 0 equals -20, y of 0 equals -10. X of 0 equals a times 0 plus b, that equals -20. So b equals -20. And in the second equation, when t equals 0, it becomes c times 0 plus d equals -10. So that means d equals -10. We used this condition to figure out b and d. We have to figure out a and c. To do that, we will use the condition about the slope. Slope is defined as y change over x change. We will assume that it passes through x of t and y of t and minus 20 and minus 10, which is a given point. Then the formula can be written as y of t minus y of 0, because this is x of 0 and this equals y of 0 over x of t minus x of 0. y of t was given as ct minus 10 because d was minus 10 minus y of 0, which was d was minus 10 again, over x of t was at minus 20 minus x of 0 was minus 20. Those are calculated. Then these two will cancel each other, and all we get is ct over at, which is c over a. We know that the slope is minus 2 in the problem, so we can rewrite that as minus 2 over 1, and we match it like this. Then we can say that c equals minus 2 and a equals 1. So x of t equals, we are going back to here, a equals 1, so 1 times t equals t, and b was minus 20. Y of t equals c we were looking for was minus 2. So minus 2t, and d was minus 10. So we got these two parametric equations. For this type of problems, you can get different but correct answers. There are infinitely many answers. In this problem, we put t equals 0, but you can assume that the parametric equations graph pass through minus 20 and minus 10 when t equals minus 1. And then you will go through a little bit harder calculational process, and you will get different set of x and y, but that answer should be also correct. In the last step, we can write, instead of minus 2 over 1, instead of minus 2 over 1, we can write it as 2 over minus 1. If we do that, then it'll change the answer because C equals 2 and A equals -1 in this case. So everything will be the same, but those will be different. So x of t will become minus t minus 20. Instead of 1, we have to put -1 here. And y of t equals 2t minus 10. Instead of -2, we put 2t. Let's graph a different type of the parametric equation, which doesn't use trigonometric functions. We have x equals 4t plus 1 and y equals t plus 1 over 4 squared. We want to eliminate t in the equation when we form the rectangular equation. So to eliminate t, we solve for t in the equation x equals 4t plus 1. To do that, we subtract 1 on both sides. Then on the left side, we have x minus 1 equals 4t. And then we divide by 4 on both sides. Then t will become x minus 1 over 4. By using the first equation, x equals 4t plus 1, we could solve for t. T became x minus 1 over 4. We will put that into the equation of y. Y equals t was x minus 1 over 4 plus 1 over 4 squared. So that is y equals x over 4 minus 1 over 4 plus 1 over 4 squared. So those are canceling each other. So y equals x over 4 squared. So y equals x squared over 16. We got the rectangular equation that is a parabola. Let's shape the parabola after we fill out the table. We will evaluate at t equals minus 1/2, minus 1/4, and 0. You will fill out the table and come back. If you fill out the form, you will get this table. When t equals -1/2, x is -1 and y is 1/16. So this happens when t equals -1/2, and when t equals -1/4, x equals 0, y equals 0. When t equals 0, x value equals 1 and y value equals 16. So we can easily figure out how the direction goes. We trace the graph in this way. As t increases, you may ask me why I chose t equals -1/2 and -1/4 and 0. What I did was I looked at the parabola and evaluated y value when x value equals -1, and I obtained 1/16. And we also know that the vertex of the parabola is 0, 0. So I wanted to get the t value at those points. To do that, I set up 3 equations. This equation comes from when x value equals -1, and this equation comes from when x value equals 0, and this equation comes from when x value equals 1. And then I solved for t, and then I got -1/2 and -1/4 and 0. But if you have any other number preference, then you can also plug that point as t.